This tutorial goes along with the Introduction to Systems of Inequalities worksheet that you should have. The first part is really just kind of reiterating what it means to be a solution to a system. So I have there, determine if a point is a solution to the system of inequalities. So really what you're trying to figure out is if each of these points, for instance on number 1, the point 5, 2, does it work in each of these inequalities? So we would just test that out by plugging 2 in for y, and then we would plug 5 in for x. So we're checking if 2 is less than 2 times 5 minus 4. And we know that 2 times 5 is 10, and 10 minus 4 is 6. So then we would know that 2 is less than 6, which is a true statement, so we know that this is correct. We would also plug it into the other equation. So we would do 2 times our x value, which is 5, minus 5 times our y value, which is 2, and we want to check if that is greater than or equal to 12. So 2 times 5 is 10, minus 5 times 2 is 10, so we're checking if 0 is greater than or equal to 12. Well, unfortunately, that is not true, which means that 5, 2 is not a solution to this system, so we would say no in that case. So go ahead, take a minute, try these on your own, pause the video, and see if you can get solutions or no solutions on these, and then come back to this. I'll go ahead and display the answers for you. You can see here that the first one we already had was no. Number 2 is yes, negative 2, 4 works in both inequalities. Number 3 is no, because it does not work in the first inequality, so you don't even have to check it in the second. And then number 4 is yes. So now how do we go about actually graphing systems of inequalities? I have the steps kind of highlighted out here for you, but let's just kind of go through this first example together. We already talked about how to graph inequalities, and now it's just a matter of graphing multiple ones on a single plane. So let's look at this first inequality. We have y is greater than or equal to 1/3 x plus 1. So this is obviously going to be a line. Because it's greater than or equal to, we want to have a solid line for our border line for where we're shading because of the or equal to. So in this case, we have a y-intercept at 1, so we can plot our point there. And our slope is 1/3. So that means going up 1 and right 3. Up 1, right 3. You can do that as many times as you want. You can go down 1 and left 3 as well, just so that we can get that full line. And again, we're going to connect that with a solid line. So I'm going to grab the solid line tool. And to show that we know it continues forever in both directions, we're going to throw some arrows on there. And we need to figure out where to shade because this is obviously an inequality. So I'm going to pick a test point. My favorite test point, as you all know, is the origin. So I'm going to test 0, 0 to figure out if I should shade towards 0, 0 down here, or if I should shade above the line. So if I plug that in, 0 is greater than or equal to 1/3 times 0 plus 1. So we get 0 is greater than or equal to 1, which we know is not true. So that means 0, 0 is not a solution, which means I'm going to shade on this side of the line. But because I'm going to be shading on 2 different inequalities, there's going to be a lot going on here. I might actually just indicate that I'm shading above this line by putting some arrows above it. I'm not going to actually do all the shading. Now that's your call. You can shade it if you want and look for the overlap of shading later. But for me, it's just easier if I don't shade quite as much throughout the problem and just wait to shade the overlap at the end. So the next one we want to graph is a line in standard form here. So I know that when I typically graph something in standard form, I look for the intercepts. So the x-intercept, that's where we plug in 0 for y. So the 8y would go away, so we would have 4x is less than 24. So really what we're solving is 4x is equal to 24, and we're just going to solve for that x there. So x would equal 6. That's our x-intercept. And then our y-intercept, we're going to figure out what happens when we plug in 0 for x. So we get 8y is less than 24, but again, we're just going to solve 8y is equal to 24. So our y-intercept is at 3. So our y-intercept is up here, and our x-intercept is down here. And if I wanted to continue this, just because I can see that I'm going to need some more points for when I'm using my ruler and trying to plot that out. So my slope is down 1, 2, 3, and right 6, which means my slope is really negative 1/2. So I could go up 1 and right 2, up 1, or I'm sorry, up 1 and left 2 if I wanted to keep going, just to get more points. Same thing down here, down 1, right 2. And I can see the rest of that line, but I could connect that with a dotted line. I'm going to go ahead and use my line tool here just so that it's nice and straight. So we have that dotted line because, again, there's no inequality, or with the inequality, there's not an equal sign. So it's just a dashed line there. So we'll put some arrows there. And now we need to figure out which side of this line are we going to shade. So again, I'm going to do a test point. So I'm going to test my favorite, 0, 0, because it's not on the line. So if I plug it in here, we have 4 times 0 plus 8 times 0, and we're checking if that is less than 24. Well, we get 0 plus 0, which is 0, which is less than 24, which means 0, 0 is a solution to that second inequality. So I want to shade on the bottom side of this line towards 0, 0. So I'm shading below this line. So the system of inequalities has an infinite number of solutions, and they all lie where that overlap is. And we can see that the overlap would be above this line and below this line, so it's basically this section in here. And so it's hard to say what is the solution to a system of inequalities. Instead, you can say what is one solution of many. So it says, give an example of a solution to the system. Well, for example, here, what about the point, let's say negative 6, how about 2? Negative 6, 2 is a point that's in that shaded region. And you would show that it works because you could plug negative 6, 2 in the first one. 2 is greater than or equal to 1/3 times negative 6 plus 1. A third of negative 6 is negative 2 plus 1 would be negative 1. And so 2 is greater than or equal to negative 1. That works there. Plugging it in the next one, 4 times negative 6 plus 8 times 2, we're checking if that is less than 24. 4 times negative 6 is negative 24, and then plus 16, we can see that we're going to get negative 8, which is in fact less than 24. So this works out. So this is really it. The worst case scenario is like a question on the back where you would have to graph both a quadratic and a line. And so it just takes a little bit more work. Maybe pause the video, see how you do on it on your own, and then come back to check with me. I'll go ahead and walk through it pretty quickly here. If I'm going to graph this quadratic, first of all, it's going to be a dashed line because it does not include the or equal to part. We need to find our axis of symmetry. We do that by negative b over 2a. And in this case, that's going to be a positive 4 over 2 times 1, or 2. So our axis of symmetry is at 2. Plugging into to get our vertex, when you plug into, you end up with negative 8. So at 2, negative 8, we would have a point. Our y-intercept is negative 4. We can see that, and we could reflect that over. So we have 3 points. I would probably plug in even more. When you plug in negative 1, you get out 1, so I could reflect that. If you plug in, for instance, 6, you get out 8. So if I plug in 6, I get out 8, which means at negative 2, 8, I would also have a point. So really, it's just a matter of connecting this with a dashed line. And mine's not perfect, and that's okay if yours isn't either. Just do your best. And now we need to figure out where to shade. So like always, I'm going to test a point. If I test 0, 0, I'm going to get 0 is greater than, these terms will go away, and it's greater than negative 4, which is true, which means I'm going to shade inside of my quadratic, inside of my parabola. And now we're going to graph the line so that we can figure out where our overlap is. This is going to be a solid line because it has the or equal to part. So we're going to graph our y-intercept at 5, and our slope is up 2 and right 3. Up 2 and right 3. You can do that as many times as you want. Down 2 and left 3. Down 2, left 3. Down 2, left 3. use our line tool. You would use a ruler, a straight edge of some sort, and we make that solid line. So now we want to test a point for this. Again, I'm going to test 0, 0. So 0 is less than or equal to 2/3 times 0 is 0 plus 5. So is 0 less than or equal to 5? Yes, it is. So in this case, I'm going to shade below this line towards 0, 0, which means our overlap is going to be inside the parabola and below the line. So it's basically all of these points in here. And you should be able to pick any of these points. For example, the point 2, 1, that's a solution, and I would like for you to show me how that actually works. I'm going to take my word for it on this one over here, but I want you to show that on your paper in your notes.